Hello, nice to meet you. My name is Ray GRIESELHUBER, as the host said. I am based in San Francisco, and I came here to Budapest. It's my first time in 11 years since being here, so I'm happy to be here again. Today I'm going to be covering a lot of material, so I'm going to be going quickly through it, but hopefully we'll have a chance to speak a little bit afterwards as well. What we work on, Functioneyes is a startup. We're based in the Bay Area, and we focus on providing and working and researching machine learning technologies and how they can be applied to testing automation. So this is an area that we're talking about today that is very interesting to us, and we see a lot of these conversations happening every day at our customers and partners' offices. So it gave us the opportunity to start thinking, what is the big picture when we're talking about testing automation? What is the big picture when we're talking about what does the next generation of testing automation technology look like? So to jump right into things, first of all, we have to define what domain we're talking about. There's obviously a lot of different layers where you can execute testing automation and build solutions for it. We decided to focus on one area because it offers, in our opinion, one of the richest landscapes for new innovation around testing automation. And we basically focus entirely on regression automation at the UI layer and above. And there's a couple of reasons for that. I'll start going through those now. First of all, one of the things that we see when we work with our customers is that the UI layer is still very challenging for people. As the keynote speaker mentioned today, this morning, that it's very easy to get rapid throughput on a large number of test cases when you're not dealing with the UI. As soon as you start dealing with the UI layer, just the natural latency and the browser response time just adds a lot of complication there. So there's a lot of opportunity for improvement. And also, when you start thinking about the type of interactions that happen at the UI layer, there's lots of different things that you need to take into account. When we looked at the different solutions available, we realized that not only was functional testing still very far behind in what it could potentially do for companies, there's also a lot of opportunities in scaling out and making much more efficient API testing, load testing, performance, and security as well. There's a guy who wrote a really great essay. The link is here. Hopefully, it'll be available in materials as well. There's a great essay where he talks about the relationship between exploratory testing and regression testing. And this was, the way he put it was beautiful, in my opinion. And what he basically said was, exploratory testing is designed to help organizations learn new things. Regression testing should be automated as much as possible because that regression testing stores the memory of that organization as it grows. And the degree to which you're successful in automating that regression testing shows you how effective your company is in accessing that memory over time. So if you want to move fast, if you want to develop agile products very quickly that respond to the market, the faster you can create those memories and respond to them means the faster you can build new product features. So it's worthwhile taking a step back and looking at what does all this stuff mean from a business context. We spend half of our time at the company talking to business people who are making the decisions about testing automation solutions, and we spend half of our time talking to technical people, and often we find that there is this great gap between the two, and so we're trying to help people narrow that gap by communicating in terms that both sides understand. And so briefly, I'm going to touch on what we've identified as the 5 biggest problems in testing automation. One, and I think this is something that anybody can intuitively relate to, is that automation engineers are expensive, they're hard to find. So this very naturally creates a bottleneck in organizations. And when you're trying to create automation, that leads to a situation where just getting started, maintaining your infrastructure, test creation, test maintenance, curation over time, is extremely challenging. In our own research, 72% of the test automation projects fail for this reason. What that means is companies get immune to broken test suites. So this is a huge problem, and I'm going to talk about why it's a huge problem in a minute. But just think for a minute about how many test cases are out there that don't efficiently reflect the current state of the product in any given organization. That means the memory that we were talking about a few minutes ago is completely broken, and you're relying on manual and outdated systems. This is where it really becomes a problem. And this is addressing the business side that a lot of people, we haven't heard them articulate this. QA and infrastructure for testing automation is currently viewed as a cost center. And it's our belief at Functioneyes that it should be a profit center. But the question is, how do you turn something that is so IT focused into a profit center for the organization. And what it comes down to is I come from a SaaS background, and I've worked with a lot of SaaS companies, and I've worked with a lot of e-commerce companies. And the thing that I discovered in scaling both of those business models is that it always depends on repeat customers, repeat business. And the reason for that is, as anyone who has some experience on sales and marketing can tell you, is that it's always more expensive to acquire new customers, to get new customers to come to your site or your application than it is to keep the ones who are already there. So if you want to scale your business, you have to make sure your retention is working successfully, keep your existing customers happy. The way to do that is make sure that QA is performing the way it should be and keeping the level of your product quality high. If you're not automating, you're not going to be able to do that effectively. And I think anyone here would buy into that message. So we want to help companies turn QA into a profit center. Once you've done that, and this goes back to the problems that we're talking about, once you've done that, you need to look at how do you actually report this back to the different key stakeholders in the organization that really care about the type of results you're getting from them. This goes into not only creating the right systems, but standardizing the message that you're delivering to them. So these are the 5 biggest problems we've identified. We call them the 5 spheres of doom for automation, testing automation. At a minimum, the smartest testing application in the world has to solve these 5 problems. So we looked at this, and we decided to understand whether or not it was possible to flip the script on a lot of the way things are currently done today. And one of the first things we realized was that if engineers are the bottleneck in creating and maintaining test cases, we should figure out a way to remove that bottleneck. This is a really interesting part of the conversation because this is where the engineers that we work with, that we talk to at our client sites and so forth, they have one of 2 reactions. Either they're like, yes, thank God, we don't want to do this because it's been a huge nightmare and we're always behind when we've got product stuff to work on. That's like half of the reaction. And the other half of the reaction is they are very hesitant to embrace this sort of approach because lots of reasons, they're thinking about their career, they want control over their organization, they think that coding is the only way to build proper test cases. And I think that it's important at this stage in the industry to make the bold statement that if you're going to scale out testing automation to solve these 72% of testing automation projects that fail, you're going to have to start doing things a little bit differently. So what does that mean then? Who creates the testing automation? We have a term that we've created called automation architects. Basically what that means is if you're removing the ability, or the requirement anyway, for engineers to create and maintain test cases, you can now think about what sorts of technology solutions can you create in order to give non-technical people, non-engineers, the ability to create those test cases. Also, we're living in a time now where, especially over the last 5 years, machine learning technology, AI technology has really come to the forefront as technologies that are accessible to a wide variety of people that were not available even a few years ago. So our belief is that the smartest testing application in the world should use a combination of machine and human intelligence. So let's talk about some specifics, because all of this may sound interesting or annoying in theory, but let's talk about what that looks like for specific customers. One of the companies that we work with in San Francisco, they're a Fortune 500 software company, $30 billion market cap, 50 engineers, 5 QA engineers, and 10 manual testers. They had a lot of problems when we started working with them. And their goal was to move faster, to build up this automation suite, but it was completely impossible for them to do so. Even with significant resources, they were even willing to hire more people. But the people who were there were smart enough to see that just throwing more people at the problem wasn't going to be the right solution. So their goal was aligned with us. They wanted to free up their engineers to work on other projects and enable non-technical people in order to create testing automation test cases. So, when you look at an organization with that amount of resources, the common question is, why don't you guys just do it? Like, just assign the engineers, make it happen, make it a project. And it's very difficult for these larger organizations. There's so much inertia moving in the other direction that prevents people from going into that. That's almost a whole other presentation in itself. So, like we said, we're going to take engineering, automation off of engineering's plate. And we're going to create a system that allows both non-technical engineers non-technical testers to create and maintain test cases, and then we'll use machine learning wherever possible to automate the system, learn about the system as much as possible as well, and then combine those two sources in order to create the test cases. If you look at the state of the market right now, there are two basic solutions that have come out that have really started to scale out and work effectively for people. One, and they're actually combined in some of the solutions out there. So one is executing the test cases on the cloud. The keynote presentation did a really good job of talking about some of the advantages of that today. Selenium Grid obviously is a step in that direction as well. And so you want to, obviously, when we're talking about what the characteristics of the smartest testing application in the world would look like, we're obviously talking about something that would be elastically scalable and executes test cases on the cloud. And furthermore, it should have transparent cross-browser, cross-device coverage. That shouldn't be something that people have to maintain on their own. We talked about reporting. We talked about the information that comes out of the system. If you go back to the previous two slides where we're talking about cloud-based systems with the cross-browser coverage, everything at that point is still driven on coding. So one of the things that we think it's really important to focus on is think about the difference between source code and data in your application. You know, if your entire testing suite just relies on source code, Selenium code, configuration files, whatever you have, you're missing a lot of opportunities in capturing what the data are in the system. And the data is what's really important, right? This is the whole reason we're doing this is so we can make better decisions about scaling the application out better. And you need data in order to create insights, in order to create better decisions. And so we're a big believer in creating reporting and dashboards that provide meaningful information not only to developers but also to the business people. We think it's possible to do this with today's technology because we've already seen some of this in our own work. We are aware of other companies that are also innovating in maybe some of these different vertical spaces. And we think that this whole industry is ripe for opportunity for innovating in this space, combining a lot of these new ideas. In our own experience, what we did was we used a couple of things in order to make it work for our customers. One was we talked about how you combine the machine and human intelligence. What we found most effective so far was creating an advanced browser plugin to create the testing workflow capture. And that allows people who are not engineers to create the test cases, curate the test cases over time. And then use a combination of machine learning technologies. I wish I had time to talk about those today. We'll be talking about them later this week. But there's so much opportunity here that we could probably talk about that at an entire conference. But machine learning has, I'm sure you're all aware, has come up into vastly new levels of practicality that just didn't exist a few years ago for many companies. So we capture the workflow using either human or machine intelligence. Then we have analysis engines that can learn the application, fingerprint it properly, and take advantage of the cloud delivery and the big data processing capabilities of different frameworks like Storm and so forth. And then they can actually be executed on the cloud infrastructure, and you receive the results from that. So the results that we had with this experiment were very successful. With this particular team that I was talking about at the software company, we were able to create 250 additional complex test cases. These are things that have 100 steps and more in less than 5 days. And the time to run their formally run their test suite was about a week. So they would do a 3-week development sprint, and then they would do a 1-week long testing sprint. And we were able to reduce that testing time down to 15 minutes for the entire suite, completely automated. And what that gives them, they still have QA engineers internally, but they're allowed to now go focus on other problems, bigger problems, instead of creating and managing test cases. This also gives the product managers, the non-technical users, the people who care about things from different perspectives than maybe an engineer would look at it, the ability to also create and manage test cases far more effectively. And very importantly for the management team, they now have the ability to gain true insight from the automation that was created. They understand how to make better decisions about the overall quality of the application. So I always like to think in terms of what are the concrete takeaways in any of these situations. And I think one of the biggest takeaways here is, again, we have the opportunity right now in this industry, everyone here at this conference is focused on this problem, I think, to use existing technology today and maybe take it even further than we thought was possible, because sometimes just by flipping the situation around and instead of focusing on how can we enable engineers to be more effective, let's think about how we can enable non-engineers to also be effective in these environments and what tools can we give them. And we also believe that right now the timing is very good to enable both humans and machines to work together in order to scale out faster. Thank you very much.
We have a question here. Do you know about any open source solutions in machine learning? Selenium of AI?
The Selenium of AI. Someone should grab that domain. I think right now when you look at open source solutions around machine learning, there's a lot of different options, and companies, individuals, they're still figuring a lot of this out. So I don't know of a single solution that allows people to just plug it in the way you would use Selenium from an open source package. That's something, follow our blog. We try to write about the trends quite a bit, so as we discover more things, we're going to be sharing as much information as we have.
Stefan is asking, how do you ensure test objectives are met when machine writes tests? Who is the judge here?
Yeah, that's a great question. And this actually goes to the heart of what we're talking about, which is the accountability in the testing system. Right now, if you think about how things currently happen, test specifications may be defined, they're coded, and then it's basically turned over to engineering, and things are generally graded on pass-fail in the test suite. Pass-fail, though, can mean a lot of different things. And one of the things that we're learning is that individual test cases can pass or fail for many different reasons. And one of the biggest problems is false positives and false negatives. So an engineer may see that a test failed. Doesn't necessarily mean that that test was bad. Maybe it does, maybe it doesn't. It also doesn't necessarily mean that the website is currently functioning correctly or not. There's still an additional level of determination in order to review that. So we think that it's actually necessary to go through and create additional levels of insight on top of that, where number one, you're evaluating the stability of that test case over time and see what that looks like. You can create scores around this. This can be used for additional learning. And then you build into your platform the ability to make these evaluations. So that's a big topic, but excellent question.
A doubt here, Ákos is saying, call me pessimistic, but I do not believe that a random guy can make a good test case as an engineer. Did you compare them?
Yeah, I love that one. So we hear this often, and the answer that we give to people when we talk to them, and they say this to us, is we'll challenge you. Give us your best engineer, give us your worst engineer, and we'll give you, and give us your best QA tester, manual tester, anyone in the organization, and we can demonstrate it to you. I think that, when you're talking with individuals, companies trying to overcome that sort of skepticism, it's something that you have to do. On a more meta level, we're kind of, at a conference and talking about how you would address that. I think it really comes down to the quality of the solution that you're talking about. And again, how do you build, it's not just about how effectively can you create the test cases, it's about what accountability can you get out of the system. Can you actually see what's going on, and can you trace everything? Can you answer with confidence that you're getting the right results? And if you can, and if a non-technical person can do that, then you're in good shape.
Tibor is asking what is used from AI. So what exactly?
Which one?
Yeah, Tibor just.
Oh, okay.
So what is used from AI?
Oh God, yeah. So everything that we've been doing, we said we have a very basic requirement, which is anytime we can use machine learning to enhance what we're doing, we should. If there are reasons where we can't do it immediately because of product constraints, that's fine, we put it on the roadmap, but we should always be thinking about how can we use machine learning to enhance every aspect of the testing platform. So we think it's everywhere, and we certainly try to do that. To give you some examples, there are different ways of looking at a website, both from the user side and also from the website structure side. There are lots of things that you can do. You can look at anomalies. One of the biggest areas of research that we do is in anomaly detection, so using unsupervised learning, k-means, clustering, and so forth, to detect anomalies on your page. And the system will learn over time and at scale what anomalies look like because it'll know what normal behavior looks like. So that's an area that we do quite a bit of research on.
The next question is about, how can you control the huge number of new test cases? Don't you need to review them sometimes?
Yeah, that's another big problem too. So you're going to have to figure out what your pace looks like in the application over time. Every organization is different. And one of the things that we're seeing is that we are working, in our case, we're working directly with our customers because when you build an application that handles testing at this level, you need to have people who are trained on using the application. We don't really believe in silver bullets. We believe in using superior technology and a superior state of mind to get people to the next level. Doesn't mean that you can't eliminate, it doesn't mean you can eliminate training. So we work with training our customers, making sure they're successful, making sure management buys fully into what they're doing, and we also provide the ability to help them get up to speed. Once that's been done, you have this initial spike of creation. The curation with the tools, if you build the right tools to curate tests over time, you can accomplish quite a bit in very short a time. So just to give you an example, we can create a new test case in 5 or 10 minutes, and that's with no coding required, and that gives people the ability to scale that out much more effectively.
Luciani Rimie is asking how your AI managed to reduce the test execution time from 1 week to 15 minutes.
Yeah, well, and to be clear, the 1 week was a combination of they had manual testing was part of that process. So there were formerly things that they were not able to automate because everything was manual and they didn't have the right engineers in place. So the first hurdle to get over was automating things that weren't automated before. So that, as you can imagine, dramatically reduced the amount of execution time because you no longer need manual testers to go through the test suite. But also, the elastic scalability that is provided by the cloud system allows you to execute in parallel your test cases. So the keynote speaker this morning talked about doing that on Selenium Grid, and we have a similar technology where we have the ability to scale out test execution as fast as you would like. So it doesn't matter if you have 10 test cases or 3,000 test cases. All of them can be run in a matter of 15 minutes or even shorter. And the question is really, can your infrastructure even handle that at that point? So it becomes somewhat of an optimization from there.
You manage complex test cases in your presentation, so Balázs is asking an example for this.
Sure, yeah. So think about anything in modern web applications today, starting from, say, take a SaaS application, for example. You go to the marketing page for a SaaS application, you're interested in a product, you're checking out pricing, you want to get a demo, so you fill out a form. Maybe you can sign up directly, you have to deal with activation, you get an email, you have to validate that email is correct. Maybe you're supporting two-factor authentication, you have to test for SMS, receipt of that message. If you're a global software company, you have different languages to support. You could be in many different markets. You need to check that the language is correctly displaying everything. You need to make sure there's not layout breakage. Once you're in the application, you have exports. You have to validate the data quality of the exports that come from that system. You have to do searches. There's navigation menus. All these things that are very complex. All these things that you should not have to have engineers dealing with writing automation for this. So the system needs to be able to support all these different things in such a way that a non-technical user can manage those test cases.
And the last, not the last question actually, one more, okay, yeah, it's the last question. What exactly these tests check or test those that are learned from the implementation?
I'm not sure I understand.
So what test cases test that are learned from the implementation? Because,
like example test cases?
Or for example, when as far as I understand this question, we want to understand, like, when because you record the test, right? So it's a machine learning, so you have an automated test that is learning from the implementation. And what exactly this test case or this test script is testing, which is learned from the implementation, because it probably the author of the question thinks that the bug or the defect is learned also during the implementation of the test script, right?
Okay. So that's probably a little bit of a follow-on to the previous question, which is what types of things can you test with this sort of system? And then I think probably the broader question is what are the lessons that companies can learn from this? And this goes back into moving beyond the simple idea of pass-fail in a test case. And it allows you to examine much more thoroughly what is the stability of your system versus what is the stability of your test cases? How much throughput can you get? Even, for example, how many test cases can you run, to go back to the previous question? If you can't run a certain amount of test cases in a short amount of time through parallel execution, what does that say about your infrastructure? Are there things that you can do there? Another example that we see is security is a huge unsolved problem for a lot of companies for a very big specific reason. Companies that are executing security scans on maybe a monthly or a quarterly basis, they're almost, just by definition, they're almost guaranteed to be far behind. The product is guaranteed to be far behind in a security perspective. They could have vulnerabilities out there for weeks or months before they're even addressed, because that system is also not able to catch up. So this is where we think that it's really important to start tying the different types of UI level testing, functional load, performance, security, into a single set of analysis, because it's going to start teaching you a lot more about your application and ensure that you're protected.